With arrays, we're able to store lots of data in the same variable. But what if we want to perform operations on each variable? Well, I suppose that we could do something like this, where we refer to each index individually. But what if we had 10,000 elements in our array? Are we going to write that line out 10,000 times? That doesn't sound like something I particularly want to do. Fortunately, we can use Java to help us out in the form of loops. The basic idea of loops is that the code inside the loop is performed multiple times, rather than us writing the same code out many times. And this means that we don't need to care about how many times something actually needs to happen. Our code is flexible enough to cope with any changes that we might need to make. The most common type of loop is called a for loop. With this type of loop, you use what's called an iterator to cycle through some of the code a specific number of times. This for loop does the exact same thing as the previous version of the code. It shows a pop-up dialog box for each individual element. So let's take a look at how it works. First up, we create an iterator. This is just a variable which is going to keep track of how many times we have run the code inside the loop. Because we're using an array, we are going to start this out at 0, so we can access the first element of our array. Remember that arrays start at 0, not 1. Then we have a semicolon and a condition. This is very similar to a condition in an if statement. In this case, the condition is making sure that the value of the iterator is less than the length of the array. The length is a property every variable has. In an array, it just tells you how many elements are within that array. In a string, it tells you how long that string is. In this specific case, foods.length is going to be 4, because there are 4 elements in our array. And when this condition is no longer true, the loop will stop running. Then after another semicolon, we have the iteration. This is an instruction which the for loop will run at the end of every cycle through the loop. The specific instruction I've used here is I++. This is the exact same thing as writing I equals I plus 1. Because this is such a common line, when Java was created, they used I++ as shorthand for I equals I plus 1. The double plus just increases the value of the variable by 1. You can use this anywhere when you're dealing with numbers as well, it's not just limited to for loops. Now you may be wondering why you need to specify that the iterator should increase at the end of each loop, but there are occasions when you may want the iterator to decrease instead, or you may want to increase it by more than 1 each time, which would then allow you to do something with every second element in an array. By making you specify the instruction that should happen at the end of the cycle, the for loop becomes much more powerful than it might otherwise be. The final change I have made in this code is that I have replaced the specific element number in the pop-up dialog box line with our iterator value. This is because our iterator is going to cycle through the numbers 0 to 3, so we can use this to keep track of which elements we want to display. Because we've used code to determine how many elements are in our array, we can now go ahead and add in as many elements as we want, and we won't have to do anything extra to our code to enable us to handle those extra elements. New pop-up boxes will display automatically. So what if you don't know how many times you're going to need to do something, or you can't determine it without actually going through the code itself? Java has an answer for you here, in the form of the while loop. While loops basically remove the iterator and iteration parts of the for loop, leaving you with just the condition, and you're able to set the values of the conditions from within the while loop itself. You're even able to use just a boolean variable here to make the process even more streamlined. In this example, we show our user a pop-up box asking them to type the letter Y. If they type anything other than the letter Y, the loop will circle back on itself and ask the user to input the letter Y again. This will continue until the user eventually does type the letter Y. This can be a great way to do input validation from a user. You create a set of conditions that the user input will be tested against, and if the user fails to pass any of those tests, your program will just ask for the input again. There is, however, one downside to a while loop, and that is the fact that if the condition is true before the code is run itself, Java will just skip over the entire contents of the loop, like if it was an if statement. This can be a problem when you're asking the user for input, because you might want to ask the user's input at least once. Java has a solution for this as well too, in the form of the do loop. A do loop is basically the same as a while loop, except that the condition is checked after the code has run, rather than before it. You can literally just select the word while and the condition and drag them both down to the bottom of the code, and add the word do to the start of the code and you're done. Like almost anything else we've talked about so far, you're also able to put any type of loop inside any other type of loop, and you can do this as many times as you want as well. So it's very easy to cycle through tables and such like very easily. Let's take a look at the two-dimensional array we looked at in the arrays section. If we consider each group as being on the x-axis of the table, and each individual food item as being on the y-axis of the table, we can create two for loops, one inside the other, and print out each individual element separately, or do anything else that we want to do with them.